Here we're going to look at question 3 from section 2 of the ENGAA 2018 paper. In this question, we're given the following circuit, which consists of a power supply connected to two fixed resistors X and Y, as well as the variable resistor W. The question then asks us, if the resistance through W was to increase, then what would happen to the power across our two fixed resistors X and Y? If you would like to have a go at answering this question yourself, please pause the video now. Otherwise, let's have a go at it. So to go about answering this question, perhaps the best thing we could do is think about some equations which might help us solve it. So, since we're being asked about the power through the two elements X and Y, the best thing to do is probably to write down an expression for the power. So, generally with circuits, the easiest expression to use is that the power is equal to the voltage across an element multiplied by its current. But what other equations are there which will be useful with this circuit? Well, another useful one is probably Ohm's law. It almost always comes up in circuits questions. It's definitely a good idea to at least write it down whenever you're having a go at one. And if we want, we could rearrange this equation to show that the current through an element is equal to the voltage across it divided by its resistance. And then what we could do is substitute this into our equation for power, giving us another expression for power. So it's quite handy having both these expressions, because we never know which one might be slightly more useful in other cases. Of course, if we wanted to, we could also substitute in that the voltage is equal to I multiplied by R, giving us that the power is equal to I squared R. But in this question, we're actually not going to have to use that one. Now, bearing all that in mind, let's have a bit of a think about element X. So the power across element X is given by the voltage across it, multiplied by the current through it. So how about we have a go at trying to find the current through the element, so that we can then try and find the power. Now, since this element X is just in series with the power supply, then we know that the current through it is just, to find the current, we can just go ahead and find the current through the power supply, through the whole circuit. So to do this, we can divide the voltage of the power supply by the resistance of our circuit. So we need to find the resistance of our circuit. Now, of course, this is just going to be the resistance of our element X plus the resistance of our parallel section here, made up of Y and W. So let's go ahead and find the resistance of our parallel section first. So, using our rule for resistors in parallel, then we get that 1 over the resistance of our parallel section is going to be equal to the reciprocals of our two resistances added together, which we can then rearrange to get the resistance of our parallel section is given by this expression here. Okay, so now that we've got this, we can go ahead and find the total resistance of our circuit, which is given by this expression. And with this, we can consider the current travelling through our circuit and thus through our resistor X. So we know that the current is given by this voltage of the power supply divided by this total resistance. We also know that as the resistance through W changes, our variable resistor, the voltage of our power supply is going to remain constant. It's going to be exactly the same. So the numerator of this fraction is just going to be constant. So all that's going to change is the denominator, which is this total resistance. Now as RW increases, then we can see that this expression is also going to increase, which is just going to be because this fraction here increases as RW increases. Now, if you're not quite sure about this, you can go ahead and plot it into a graph plotter of some sort and have a look at the graph, and you'll see that it's actually going to travel up, but it will sort of reach a bit of a point where it levels off a bit. Nonetheless, it does increase as RW increases, and therefore our denominator is going to increase as RW increases. The resistance across W increases. So with a constant numerator and an increasing denominator, we know that our current is going to decrease. Okay, so what we can do then is consider the voltage through X, or the voltage across X, sorry. So this voltage across X is going to be found using Ohm's law. So the voltage is going to be equal to the current through X multiplied by its resistance, which we know isn't going to change because the X is just a fixed resistor. There's nothing changing about its resistance. But we also know that the current through X is decreasing. So that means that our voltage is going to decrease as well. Now, if our current and voltage are both decreasing, then we know that the power on X, or the power being dissipated across X, is going to be a decreasing value multiplied by a decreasing value, which is going to be decreasing itself. So the power on X is going to decrease as the resistance across W increases. Now that we know this about X, we can go ahead to consider resistor Y. So one of the things which we just found out is that the voltage across X is decreasing. Now, we also know that the voltage of the power supply has to be shared between X, resistor X, and this parallel section here. So, if the voltage across X is decreasing, then to keep the total voltage the same, the voltage across this parallel section must be increasing. Now, one of the things we also know is that the voltage across W is exactly the same as the voltage across Y. So, therefore, the voltage of each of them has to be increasing. Now, this is really handy because we can go ahead and use this information and compare it with the equation we wrote down for power earlier. The power through an element is equal to its voltage squared divided by the resistance of that element. So, if we consider Y, where we know the resistance is just going to be constant, what's going to happen to the power across that element? Well, we know it's going to increase. So, the fact that the power on Y increases and that the power on X decreases is going to correspond with answer C given in the question.